Hello friends, I welcome you to my YouTube channel Back PM. So in this video we will solve numerical problem which is based on eccentric loaded riveted joints. Okay, so let's read the problem. A bracket is riveted to a column of 6 rivets. So there are 6 rivets which are given. Suppose we are giving them some number 1, 2, 3, 4, 5, 6 of equal size. So they have equal diameter. So diameter is same, okay, for all rivets. It carries a load of 60 kilonewton. So P is load which is 60 kilonewton, means 60 into 10 to the power 3 Newton at a distance of 200 mm from the center of the column. So this, suppose this is the center of the column, so it is 200 mm from the center of column. Okay, so E is equal to eccentricity which is 200 mm. Now if the maximum shear stress in the rivet is limited to, so tau maximum allowable shear stress is 150 megapascal, which is equal to 150 into 10 to the power 6 Pascal or Newton per meter square. But this is in mm and this is in meter, so we have to convert everything in the same unit. So we can convert it as 150 Newton per mm square, okay, which is equal to 150 into 10 to the power 6 Newton per meter square. If you want to know how, see, 1 Newton per meter square is equal to 1 by 1 Newton per 1000 mm square, okay, because 1 meter is equal to 1000 mm, so it will become 1 Newton divided by 100 to the power 2 is equal to 1000 to the power 2 is equal to 10 to the power 6. So it will become 1 by 10 to the power 6 Newton per mm square, which is equal to 1 Newton per meter square. Okay, so from here you will get this value is equal to this value. Okay, so after this we have to find the centroid of this, or center of gravity of this plate. Okay, so if you see, if you draw a vertical line here and if you draw a vertical line here, then you will see that this, all the rivets are symmetrical around this vertical line and these are symmetrical also around this horizontal line. Okay, so we can automatically say that its center of gravity will be at middle of the plate at this point. Okay, so we don't need to find the center of gravity. Now as we know, there is a load of 60 kilonewton. So how will this load act? So this is direct shear. So if we transfer this load here, suppose we are taking another diagram, the same diagram, it is same diagram, but we will zoom it. See, if this is 60 kilonewton load and this is the center of gravity of the diagram of the plate, then if we transfer it here, then it will become 60 kilonewton load plus there will be a moment, by moment, because at a distance of 200 mm, so 60 into 200, that will become moment here. Okay, so this load 60 kilonewton will be taken equally by all the rivets. This is 1, 2, 3, 4, 5, 6. They all will have same amount of direct shear. Suppose this is PS, so all will have PS. So what will be the value of PS? So PS is equal to 60 kilonewton divided by how many joints rivets are there? 1 2 3 4 5 6. So divided by 6, so it will become 10 kilo Newton. Okay, so load equal to 10 kilonewton will act on direct shear, which is direct shear load will act on all the rivets equally. Okay, now we have to find what is the moment. So this moment M is equal to P into E, which is 60 kilonewton into 200 mm. Okay, so this is moment which is acting here. So all the rivets will try to resist this moment. So what will be the value of moment which will be resisted by each rivet? It will be proportional to the distance from centroid. So how will we find the centroid distance from centroid? Let's remove it for clarity. So this is centroid. We will connect center of all the rivets from here, centroid. Okay, so we have to find the values. Suppose this is L1 because this is rivet number 1, L2, L3, L4, L5, L6. Then if you can see from the diagram, from symmetry, L1 is equal to L2. Let's connect this so that we can easily calculate the value of L1, L2, L3, L5, L6. So if you can see the diagram, this L1 is equal to L2, sorry, L1 is equal to L3 is equal to L4 is equal to L6, which is equal to, if you see this triangle, then it is equal to L1 is equal to some this is the 90-degree angle. So from here we can apply the formula. L1 is equal to root this length. What is this length? This length is given as 75 mm. So 75 square, this is Pythagoras theorem, plus this distance is 50 mm. So 50 square. So if you calculate it, you will get 90.1 mm. So this is L1, L3, L4, L6. What are distances are remaining? L2 and L5. So L2 is equal to L5 from symmetry, and if you see L2 is equal to this distance, which is 50 mm already given. So we have found all the distances. Now, as you know, the amount of moment resisted by this is equal proportional to distance of it rivet from the centroid. So we can say P1 is proportional to L1, P2 is proportional to L2, P3 is proportional to L3. If you call P, we already named this load as P, so let's rename it as F1, F2, F3. So F1, F2, F3. Okay, so we can also say that F1 is divided by L1 is equal to F2 divided by L2 is equal to F3 divided by L3, and so on up to F6 divided by L6, because there are 6 rivets. So from here, if you take these two, then you can write that, see, if you multiply like this, then F2 is equal to F1 L2 divided by L1. Similarly, if you take this and this, F1 by L1 is equal to F3 by L3, so you will get F3 is equal to F1 L3 divided by L1. Okay, similarly up to F6, so F6 is equal to F1 into L6 divided by L1. Okay, now there was a central moment around this point due to this eccentric load, which was PE. So if we write it as PE, which will be equal to all the moments offered by these 6 rivets. Okay, so we can write PE is equal to F1 L1 plus F2 L2, these are the moments by rivets, plus up to F6 L6. Okay, So we can write P was equal to 60 kilonewton. So 60 into 10 to the power 3 into E was 200 mm is equal to F1 L1 plus, if we see value of F2, what was it? See, we have calculated F2 is equal to F1 L2 by L1. F3 we have also calculated, so it will become F1 L2 divided by L1 into L2 plus F3 is equal to F1 L3 divided by L1 into L3 plus, similarly F6 is equal to F1 into L6 divided by L1 into L6. Okay, so this is moment offered by all the rivets. So it will become equal to, if we take common F1 divided by L1, if we take it out, then it will become L1 square plus L2 square plus like this up to L6 square. Okay, now it will become F1 divided by L1 in bracket. As you know, we have already seen that L1, L3, L4, L6 are equal, so it will become, if you put all the values, then F1 for L1 square plus L2 is equal to L5 here to L2 square. Okay, so this value is equal to how much? F1 we don't know, we will put F1 divided by L1. What is L1? L1 we had calculated 90.1 mm plus into 4 into 90.1 square plus 2 into L2 was 50 square. So it will become, if you calculate it, then you will get 416 F1. So F1 will be this value divided by 416. Okay, so F1 you will calculate, you will get 60 into 10 to the power 3 into 200 mm divided by 416. So it will become equal to 28846 Newton. Okay, so this is the value of F1. So from here you can calculate F2. F2 is equal to, if you remember, F2 was equal to F1 L2 by L1. So F2 will become equal to F1 L2 divided by L1, which will be equal to 28846 into 50 L2 divided by L1 was 90.1. So it will become equal to 16,008 Newton. Similarly, F3 was equal to F1 L3 divided by L1, which will be equal to 28846 into L2 and L1 was equal, so it will become L1 by L1, sorry, L3 and L1 were equal, so it will become L1 by L1. So F1 is equal, F2 is equal to, sorry, F1 is equal to F3. Okay, so similarly, because L4 is equal to also L1, L5 is equal to L2 and L6 is equal to L1, so we can find out that F1 is equal to F3 is equal to F4 is equal to F6, because all the distances L1, L3, L4, L6 were same, so it will become 28846 Newton. Similarly, L2 was equal to L5, so F2 will become equal to F5. So F5 is equal to F2, which will be equal to 16,008 Newton. Okay, so we have found all the forces. Now if you want to find the distances, so in which direction these moments will act. So see, this is the radial distance, so it will act perpendicular. You see the central moment was acting in this direction, clockwise direction. Okay, so all the movements will also act in the same direction. So if we see, it will be perpendicular to this radial force, radial distance, so it will become like this. This is F1, then this is F2. All the forces will be perpendicular to this distance, and then F3, and then F4, and then F5, then F6. So if you see the diagram, suppose this is theta1, this is theta2. Theta is the angle between direct shear forces and secondary shear forces, PS and F. Okay, this is theta3, this is theta4, this is theta5, this is theta6. Okay, so if you observe this, if there are two forces, if they are in the same direction, then their magnitude, resultant force will be very big. So if you see this at point 1, the forces are having very small angle, or they are almost in the same direction. At F2 they are perfectly in the same direction, downward. F3 here also angle is very small, but if you see at point 4, they are acting in almost opposite direction. F5 there and PS5, PS and F5, they are acting perfectly opposite direction, 180 degree, and similarly F6 and P6 are also in PS, also in opposite directions. Okay, so from here you can see that resultant force will be very big at point 1, 2 and 3, rivet 1, 2, 3. You can also see that R is equal to resultant force is equal to, suppose there are two forces, so F square plus PS square plus 2F F1 into PS cos theta. Okay, so from here this will be same for all the loads, but what is the variable here? Theta. So theta, if cos theta is very small, then cos theta will be very big. So this factor will be very big if theta is very small, but if theta is suppose 90 degree or big, then this value will become negative or 0, near 0. Okay, so we have to see if theta is very small, so we have to catch those those points. Okay, so if you see 1, 2, 3, so rivet 1, 2 and 3 are heavily loaded. Okay, why? Because there are these two forces, PS and F, primary and secondary shear forces, are almost in same direction, or in other language you can say that theta is very small. You can also calculate resultant force on all the 6 joints, then you can compare. Okay, but to save time we are just calculating in 3 joints, because we already know that force will be maximum, resultant force will be maximum at point rivet number 1, 2 and 3. That's it. So okay, so if you want to find the theta, so this is theta 1. Okay, so this is theta 1, so this will be 90 minus theta 1, so this will be theta 1. Okay, so what will be the theta 1? So if you calculate theta 1 from the triangle, cos theta 1 is equal to this 50 divided by 90.1, which will be equal to 0.555. Now if you see from the symmetry, theta 1 and theta 2 are same, so it will be also equal to cos theta 2. Okay, so we have found the value of cos theta 1, cos theta 2. Now here if you say theta is 0, because both the loads are in same direction. Okay, so we will find the resultant force. R1 is equal to R3, resultant force at rivet number 1 and rivet number 3 is equal to PS square at both primary shear load plus F1 square. F1 and F3 are same, that's why R1 and R3 will be same, and angle is also same, plus 2 PS into F1 into cos theta 1. So if we'll see why R1 and R3 are same, because F1 is equal to F3 and theta 1 is equal to theta 3. Okay, so it will become PS was 10 kilonewton, which is 10,000 Newton square, plus F1 was 28,846 Newton square, plus 2 into 10,000 into 28,846 into cos theta is cos theta 1 is 0.555. So if you will calculate it, you will get 35,348 Newton. Okay. Similarly, R2 resultant force at point number 2, rivet number 2, both loads are in same direction, so they will simply add up PS plus F2 is equal to 10,000 plus 16,008, which is equal to 26,008 Newton. So if you see from here, maximum load will be acting on rivet number 1 and 3. 1 and 3 are most heavily loaded. Okay, so if D is the diameter of the rivet number 1 and 3, so D is diameter, so area is A1 is equal to A3 is equal to pi by 4 D square. Okay, now total load is 35,348 is equal to area and shear stress, so pi by 4 into D square into tau shear stress. So what was tau? It was 150 Newton per mm square. We have seen in the question. So it will be equal to, if you calculate this value, then equal to 117.8 D square. Okay, so D square will be equal to 35,348 divided by 117.8, which will be equal to 300.4 mm square. So if you will find D, it will become root 300.4, so it will become 17.33 mm. So this will be our answer. So this is the minimum diameter of the rivet. It can be more than this, but if it will be less than this, then the shear joint will fail. Rivet joint will fail. So it can be more than 17.33. Okay, so I hope you understood this problem. If you have any doubt, you can ask in the comment section, and if you like this video, then please share and subscribe to our channel. Thank you for watching.